In this unit, we're going to be talking about how we can solve systems of equations. Today, we're going to focus on how we can solve a system of equations by graphing. So what is a system of equations? A system of equations consists of multiple equations and multiple variables. In this class, when we're solving systems of equations, we're going to be solving systems with two equations and two variables. We'll call them x and y. Now, anytime you solve a system, you need to give values for all missing variables. So it's not good enough to just say x equals this and be done with the problem. You have to solve for all the missing variables. So if there are two variables, then solve for both x and y. So there are a couple methods of solving systems of equations. The first is by graphing, which is the method we'll focus on today. And there's also substitution and elimination, which we will get to in future lessons. Take a look at example 1. We have y equals 2x plus 3 and y equals negative 2x plus 7. Let's go ahead and start by graphing each of these. So start with y equals 2x plus 3. Our y-intercept is at 3 and the slope is 2. So I'm going to go up 2 and to the right 1. So there is my line. Now you may find it helpful to graph multiple points, as it can make it easier to find the solution. Alright, next we have y equals negative 2x plus 7. I'm going to find 7 on the y-axis. And then this has a slope of negative 2, so I'm going to go down 2 and to the right 1. Now the solution to this, because we're not just graphing here, we're trying to solve this. That means we're trying to get a value for x and for y. Our solution is the point at which these two lines intersect. Now the point at which it intersects looks like it is at 1, 5, so x equals 1 and y equals 5. That is my solution to this system of equations. Alright, let's look at the next example. We have y equals 2/3 x plus 2 and y equals 2/3 x minus 4. Let's start with 2/3 x plus 2. My y-intercept is at 2, and my slope is 2/3. So I'm going to go up 2 and to the right 3. Alright, next we have y equals 2/3 x minus 4. Let's start at negative 4 on the y-axis, and I'm going to go up 2 and to the right 3. Now you may have noticed that these two lines have the same slope, which means the two lines are parallel, as you can see in the graph. If two lines are parallel, we know that there is no intersection point, because that's the definition of parallel lines. So since we have parallel lines, there's no intersection, we would say that this has no solution, because there's nowhere where these two lines will ever cross. Alright, let's take a look at example 3. Y equals 1/2 x minus 3, and y equals 2x minus 6. Let's start with 1/2 x minus 3. So we're going to start at negative 3 on the y-axis, and my slope is 1/2, so I'm going to go up 1 and to the right 2. Alright, now we have y equals 2x minus 6, so I'm going to find negative 6 on the y-axis, and this has a slope of 2, so I'm going to go up 2 and to the right 1. And that is the graph of that second line. Now remember, here we're trying to solve the system, so we want to know what x and y are. So we look for the intersection point, which looks like it's at 2, negative 2, which means x equals 2 and y equals negative 2. So that's my solution to this system. Alright, the last example. Y equals negative 1/3 x plus 6 and 3y equals negative x plus 18. Now you'll notice in the second equation that we don't have this equation yet in slope-intercept form. So I'm going to put it into slope-intercept form by dividing both sides by 3. So dividing both sides by 3 will leave me with y equals negative 1/3 x plus 6. Now you'll notice that means that these two equations are actually exactly the same. Now what does that mean? Well, if we're graphing this, that means that if I graph the first line, negative 1/3 x plus 6, I start at 6, I go down 1 to the right 3, and so on. And then if I do the same thing with the second line, I start at 6, and I go down 1 to the right 3 again, I end up with the exact same line. Where do these two lines intersect? Well, everywhere on that line. So we would say that this is going to be an infinite number of solutions, and those solutions are the ones that are on this line.